Looks like it's just you and me.
Yeah, well, give them a couple minutes. We are early.
Yeah. So it's 10:30, 8:30, 9:30, it's 7:30 in the morning.
Yes.
Yeah, these ones that are at 10 a.m. are tough for all the West Coasters. Me, I'm
Uh,
getting I'm getting ready for lunch. So this is still on my calendar. So I'm guessing it wasn't canceled.
OCP thing. No, Bobby is here. So,
Oh, there's Bobby.
hello, Bobby.
Good
Ireland,
morning.
Howard. Oh, yep, Howard. I don't think is this the first time you joined the group?
Oh no, I've been on here a long time and I just don't usually say anything.
Oh, yeah. 'Cause I thought it would, most of Raymond is extremely vocals and give a lot of contributions. So
Yeah. Well, I don't.
so is you are more into the optical side or you're
I'm a mechanical guy.
uh-huh.
Many years at TE, 20 years, 30 years at Tyco. Uh,
Okay,
Mostly in high-speed backplane stuff and very little into optics stuff.
I see. Yeah, I think today's meeting is probably going to be fairly small amount of people because I think there's a OIF meetings
Oh, if
in
there's
the
OIF,
area.
then if
Yeah,
there's OIF, then everybody's going to be paying attention to that.
right. And I think it's a oversea meeting, the Q4 meeting, so they all have to travel. Uh, so so I think we'll just probably can end early and chat a little bit. So I'm curious one thing because since you're in the backline, that's wonderful because one thing that I always wanted to know is how um how does a backplane oh hi Bijan, hi Michael, hi Siamak, um is the all those like uh optical fiber or uh waveguide implanted into the PCB things, how do you think of those things?
Well, those have actually been around for a really long time. I remember optical backplanes being a thing 20 years ago. And so you bury the fiber in between the layers.
Mm-hmm.
Um, but optical fibers normally rely on, of course, reflections off the outer diameter, and there's an inner layer and an outer layer and all that. And so if you arrange your fibers in between the laminates,
Mm-hmm.
um, and somehow are able to extend them out the edge, which ends up being a problem because you end up running a route around the outside of the board to make it, after you've, crushed the 10 layers or 5 layers or however many there is. Um, so you have to abut that
Mm-hmm.
edge
Yeah.
because you can't rise up through the layer, so it has to come out the edge,
Yeah.
which poses a problem for even if you have like a SD, you know,
Mm-hmm.
the how do you hold on to that edge and um, get a good connection on this ugly routed fiberglass edge? So you go in there and you polish the edge, or so that, there's that classic problem of exiting the PC board, um, and having a clean mate.
Mm-hmm.
So, yeah, and that's, like I said, they've been around for a very long time, people
Mm-hmm.
trying to have a nice, it would be nice if you could have it hanging out like spaghetti out the edge. Um,
Yeah.
but that makes for problems, because
Uh,
normally you have a 2 foot square, 2 foot by 2 foot platter
uh-huh.
that has half a dozen, or depending upon how big your board is, that you've got to cut all those little boards out. How do you
Mm-hmm.
how do you get the fiber loose? It'd be nice to be able to have that, like I said, hang out the edge and put an SD on the end, or MPX, or whatever it is that you're trying to link to. And also, you have to make a pretty hard right-hand turn to get out the top. So,
I
um,
see.
if you do
And
it
then,
on the if you do it on the top surface, you might as well just
Mm-hmm.
leave them free, the fibers.
Yeah.
could could somebody just provide some context for this call? Maybe I missed the first minute or two. Why are we talking? I'm just curious how we got on the topic of embedded fibers in
Oh.
Well,
PCBs.
that's an easy one. We were waiting for everybody to show up, and I just kept talking.
Oh, okay, all right. And you're talking, just out of curiosity, most of the historical work for this was multi-mode, I think, waveguides embedded in PCBs.
Yeah.
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 Yeah, because I was curious, like, in many of these in the rack things, and recently people are removing the backplane, but the backplane is still very useful for
Structure, if nothing
yeah,
else.
many cases. So that's why I'm thinking, could one day this kind of optical backplane come back, or I knew it's been around for many years but never take off. So that's why I don't know, what is the challenge for that? That's why I asked Howard about it.
Well, there's the other sort of optical backplane, in that there would be no piece of fiberglass. It would just be um, a surface area spread out of regular fibers of any kind, right? And you really wouldn't embed the fibers in layer number two, three, four, or five.
Mm-hmm.
Um, so, like I said, if you want to stick them on the top surface, you can do that, but that gets in the way of devices. But you could route them around, I guess. So, but that history of mine goes back 20, 30 years.
Got it.
There's also a big effort now in a number of sectors for these expanded beam non-physical contact connectors that can enable blind mated backplanes with high spatial density, and that may cause somewhat of a resurgence in some of these concepts. Not so much the routing of the fiber in or on PCBs, but getting some amount of fiber off the front panel and pushing it to the back.
No, I see. Yeah, I that is the first time I heard the things you just described, Michael. So I didn't know anything about that. And um and what are you guys thinking about the glass substrate or the glass core into the PCB things? Are they gonna be one way to implement optical channel in the future?
I certainly am not one to look and have any feeling or opinion about what's occurring in the future, but I just bring some ancient history in.
Mm-hmm.
Yeah, on the PCB recently, there's some talk about using microwave waveguide I believe from a dimension and matching the wavelength of the EM wave, that may be a little bit easier compared to the laser. I'm not an expert in this field, so I really don't know, but that's just a guess. But doing that, um, I just don't know the manufacturing tolerance, how much it will affect the quality of the waveguide. Because PCB, we can etch it, we can put things on top and embed. That's not difficult. The technology is there for a long time. It's
Mm-hmm.
just the control of it. And then you have twists and turns,
Mm-hmm.
unless you manage to do it in a straight line. So all those details, but it is possible. Is it going to be like at as high frequency for light? I just don't know.
I see.
Yeah,
It's an interesting concept, you having a microwave on the
yeah,
board.
yeah. Yeah, and it's not new. I used to work for Intel, and it got to be at least 5, 6 years ago already. Intel lab had prototype on it, but it didn't go anywhere at the time. So
The channel that's being used for the microwave technology is not glass. It's some complicated fluorinated polymer. I don't know what it is. And then the waveguides themselves, the fiber, the plastic or polymer fiber, still has extraordinarily high loss. So it becomes a hollow core device where most of the microwave is propagating in air holes that are in the fiber. So it's a complex channel that's, I think, still under development.
Wow. That's really cool. Just like the fiber core becomes a microwave channel core and then can.
yeah, but Bobby, if you are thinking about beyond the 200G, maybe I can share something on screen really quick just to help you to help people to visualize what I try to explain.
Sure. That'll be
Yeah.
great.
So can you see my screen?
Yeah, it just came out.
Yeah. So this is currently what we have on the market. Good to
Is that the Paladin?
224, right? This is backplane.
Uh-huh.
And of course, clearly these are just copper, right?
Mm-hmm.
But if you can imagine when we get to 400G and if we want to keep the density, the physical density, the likely scenario for backplane is two things. One thing is either CPO and somehow the optical fiber from the CPO make a direct physical contact here into the
Mm-hmm.
backplane connector and just keep going.
Yeah.
But that's one way. Another way is if the connect if depending on the conversation, PAM4 versus PAM6 and whatnot, and maybe we can do a CPC and go near let's say this is the PCB here, and go
Mm-hmm.
near the to the connector, and right here is the optical engine, and
Mm-hmm.
feed into optics from here. So that's two scenario I think is
Mm-hmm.
straightforward, and we don't need to deal with the ugliness of the PCB with high speed either copper or waveguide,
Right.
and 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 it seems the industry is kind of going that way already because for even for 224G, uh, routing on the PCB is really short. A lot
Yeah.
of the application is gravitating toward flyover cable. So
Mm-hmm.
yeah, so just my 2 cents. Uh, but I'm a copper guy. I really don't know the how the optic is going to take off from here. So just
So
just my yeah.
I think this is actually very interesting because um I could picture that, if our group's next step is going to define something for OCP in a high density, high speed connector that can implement it on the OCP uh, defined compute the high performance computing board. Um, this connector is probably the widely adapted connector for now, right? And and how can we leverage these things in as one of the signal uh, input signal things, and then have the optical to coupling in it. It's gonna be an interesting topic.
Yeah, yeah, and especially for 400G, I started to look around and see if I have any data for the 400G, and
Mhm.
hopefully by next week this time I can write down something for the white paper. Going to start with some of the known connector that may have the bandwidth to go all the way to 400, even for PAM4.
Mhm.
You look at this one, right? This is you cannot read the number, but this is 90 gig here.
Yeah,
This is 90 gig,
but 90 gig over
and
there. Oh wow.
if I can, if this is just optimize a little bit more,
Yeah.
it's good to 400G PAM6.
Right.
So
Pam.
so my thinking is do a quick survey either with internally and what I have seen on the floor in OCP to
Mhm.
see when we push the bandwidth around 100 gigahertz, what is there and what kind of loss. Then depending on the where we go with PAM4 versus PAM6, then I can do it's not going to be long. The a short paragraph, maybe 2 or 3 paragraphs, just talking about what the role of copper is. From there, hopefully, the optical expert in this group may be able to pick up and think about how it transition to optics. Yeah, but once we get to 400G, it actually simplifies things for copper because it's just so tough. So
Just just be the
there's not much I
connector
can do
and
anymore.
deliver the signal.
Yeah. Okay.
Yeah. Thanks, Raymond. So I think this week is I didn't prepare things on. I don't have anything on the agenda because I'm still, getting the people assigned to the 400G things, working on it, um, and also, still organizing the white paper. Um, and and people are, I think this week is also the OIF uh, weeks, or maybe the next week, because I know people are traveling
Next
at the
week.
moment.
Yeah.
Yeah. So, Bijan, are you going OIF?
I couldn't go to this one, but one of my colleagues is going.
Okay. Yeah. So yeah, so I know people not able to join in this week and next week just because of that. So um, so I'm open up if anyone has anything like to discuss for now.
I have a mechanical engineer question for electrical guys.
Yeah.
Um, one of the pieces that came up just up the transcript here was about using waveguides. And my experience with RF has to do with high power vacuum tubes, like, a foot and a half in diameter sort of power tubes, and the cavity that matches up the frequency and the tunnels that the RF travels through, and obviously a very different frequency than we're talking about here. Um, but how physically can we transition between waveguides and optics? Obviously, optics is a waveguide of sorts, but just what is the scope of this waveguide idea, and can it be balanced between, transmitters and receivers and that sort of thing? I just, as a very generalized question, what would be the diameter of a waveguide?
Howard, you can think of the waveguide we just talked about as some form of very similar to a copper trace on the PCB board
Okay.
in terms of physical dimension.
My
And
imagine.
I think a company called eTube. I
Mhm.
forgot the company name. You can actually Google that.
E-tube is plastic. Yeah. Mhm.
Yeah, yeah.
Right.
So the concept is very similar.
Uh, uh,
And
how about the precision of laying out those, call it traces or wave guides? They for electrons, the precision is not as important, but for wave guides it might be, right?
Oh,
yeah, yeah.
complexity is skyrocketing because 224 seems hard for traditional PCB designers. 448 and then terahertz is going to be like ridiculous.
Yeah, I agree. I agree.
But if some
And
company if some companies have done it, it's good to know how they do it, how successful they are, what is the yield. Uh,
I think it looks like optics a lot because, optics right now, I know that you guys were talking earlier about embedded waveguides, but that's just not how things are being designed right now. Everything is with flyover cables, basically. So what it looks like in these optical systems are, you have this kind of base layer of electrons that are doing things like SerDes or whatever. And then for I/O, they have like a whole other layer, which is sometimes even on a separate tray, right? And in this second tier, if you will, is all the optics. And I could see the same thing happening for terahertz too, handled exactly the same way.
So, my vision of a waveguide is a hollow tube of a given length and balanced for the frequency. So, do we have a incredibly small diameter tube that the
Yeah,
waveguide travels in, or we talked about maybe like a puffed I forget the word, Teflon inner liner that the wave travels through, like just like the optical wave.
if perhaps the laser is multi-mode, if they're not worried about precision, maybe these things can work.
yeah.
Look,
I think Andrew Welch at Attitude has that solution, right? I think Um, his vision is that it's a hollow tube resonating, um, I guess you'd call it fiber, really, to be honest with you. And then so the inner core is where the optical wave propagates, and then the outer core is where the terahertz wave propagates.
So this would be a flyover sort of bundle of tiny tubes.
Yeah, I mean, and the thing is, I designed, we worked with terahertz at another place I worked, and I can tell you that it's really hard. Um, Yeah, you think you have connector problems with optical. Terahertz is not very kind. It's more mean. So yeah, also I don't know, the precision of the HVMs, I mean the ODMs to put these things into production. I don't, I mean, that's really hard step for them, like how can they make and fabricate cables at terahertz, they have to be very exact. Like they have to be like sub-millimeter accuracy. Otherwise, you have things like reflections and so on. So I, it's really hard. I'll just say that.
Right, because of those things many years ago, HB Labs was studying doing these things in silicon. You just etch the silicon, so that's precise.
Yeah.
But in that case, things are not as long.
That makes much more sense than trying to overlay it like a compute tray with terahertz, which is really hard.
Okay, thank you.
And the thing so I had Andy Welch on stage at OFC like last year, I think it was. And the thing that I couldn't converge with him on was like, what's the power level requirement for a terahertz? Like, what's the reach basically, right? What's the reach? And he claimed with signal processing tricks that it could be pretty, anything that you need on a system tray level. But I was struggling to understand how could they do that? But to be fair, I love new ideas, and it's a new idea, and I encourage people to take big swings at things. You never know what could come out of it.
That's totally true. Yeah. Right. So I think for next week, we'll see if people have things pops up. If not, I'll probably cancel the
Hey,
meeting again next week because OIF
you should definitely send out like a reminder to everybody, like what the activities are. Like if I think the white paper should be in development, right? Everybody should be
yeah,
working on it. So you definitely send out a reminder to everybody, like where the white paper is and what needs to be done, and put some like due date, like hey, like when we come back the week after OIF. For those of you who are not in Bangkok with IEEE, it's a
Mm.
busy time of year. Then we'll review whatever updates that you have or something. You know what I mean?
Yeah, definitely. Yeah, thanks for reminding me that. Yeah, so okay, so if nothing else, I think we can adjourn the meeting.
Thanks for letting me commandeer this meeting today.
That's all good. Thanks. Yeah, thanks, Howard.
Thanks, everyone.
Yeah, thank you.
Good night.